Hi, my name is Persia. Me and my group mates will be introducing our novel product, a high-quality biopreservative named Ecoshield Plus. The main purpose behind the invention of our product is the concerning challenges that we are facing in today's world, such as the possibility of food shortage, which could occur in the coming years due to the high volume of food wastage. Therefore, we designed a biopreservative which works by colonizing the surface of the fruits and vegetables and producing antimicrobial compounds that inhibit spoilage-causing microbes. The EcoShield Plus can be applied to fruits and vegetables either before or after harvesting. It can be sprayed directly onto the product or applied as a wash. It can also be sold to the farmers to be applied on fruits and vegetables at a larger scale. Moreover, EcoShield Plus is safe for human consumption and it is environmentally friendly because it is composed of all the natural components such as lactic acid bacteria, cranberry extract, green tea, as well as grapeseed extracts.
My name is Aditi, and I will be discussing the aim of this project, which is to develop and implement a microbial-based biopreservative called Ecoshield Plus for fruits and vegetables, with the goal of increasing their shelf life, reducing food waste, improving food safety, and promoting sustainable agricultural practices. Now on to the objectives of the project. The first objective includes to develop, optimize, and ensure the effectiveness, safety, and practicality of a microbial-based biopreservative for fruits and vegetables. Under this objective, specific strains of beneficial microbes which are capable of inhibiting spoilage-causing microorganisms on fruits and vegetables can be identified. Next, extensive research, testing, and optimization can be conducted to ensure the efficacy, safety, and practicality of the biopreservative formulation. And lastly, the formulation for practical application methods and scalability can be optimized considering factors such as ease of use, compatibility with different produce types, and cost effectiveness. The second objective is to facilitate the implementation and adoption of the microbial-based biopreservative. The way to go on about it is to collaborate with farmers, agricultural organizations, and the food industry to establish partnerships and integrate the biopreservative into their processes and practices. To conduct comprehensive field trials to evaluate the effectiveness of the biopreservative on a wide range of fruits and vegetables, and also to develop and provide training programs and educational materials to stakeholders, including farmers, distributors, and consumers to ensure the successful adoption and proper application of the biopreservative. And the third objective, and one of the most important ones, is to promote sustainability, responsible agricultural practices, and awareness of the microbial-based biopreservative. In this objective, the environmental impact of the microbial-based biopreservative can be assessed and compared with conventional chemical preservatives, considering factors such as carbon footprint, waste generation, and ecological effects. One can also advocate for and promote sustainable agricultural practices, encouraging farmers and the food industry to adopt eco-friendly solutions and reduce reliance on harmful chemical preservatives. And finally, to raise awareness among consumers about the benefits of using the biopreservative, including its role in reducing food waste, improving food safety, and supporting sustainable agriculture. By achieving these objectives, the project will contribute to the development and implementation of a microbial-based biopreservative called EcoShield Plus. Now I hand over the presentation to my other group member to present further. Thank you.
My name is Anishka, and today I would like to discuss the careful process involved in selecting, preparing, and producing EcoShield Plus, a probiotic product with superior health benefits. EcoShield Plus is formulated using diverse and potent lactic acid bacteria strains known for their probiotic properties. Strain selection. The first step in the production of EcoShield Plus is the careful selection of diverse and potent lab strains. Lab strains are chosen for their probiotic properties, ensuring they provide beneficial effects to the consumers. Culture preparation. Once the lab strains are selected, they are cultured in a controlled environment. Suitable growth media are used to promote the proliferation of lab strains, allowing them to thrive and multiply. Fermentation. The cultured lab strains are then transferred to a fermentation vessel and allowed to ferment under controlled conditions. Factors such as temperature, pH, and oxygen levels are optimized to ensure the best possible fermentation process. Addition of natural ingredients. During fermentation, 100% natural ingredients such as cinnamon, cranberry, and green tea leaf extracts are added to the culture. These natural ingredients provide additional health benefits and contribute to the overall formulation of EcoShield Plus. Extraction and concentration. After fermentation, the fermented culture undergoes a careful extraction process. Beneficial bioactive compounds and probiotic metabolites are extracted using optimized methods to ensure efficient extraction. Formulation. The extracted compounds and probiotic metabolites are carefully formulated to create a convenient dosage form, such as capsules or liquid. Stability and compatibility of the ingredients are taken into consideration during the formulation process. Quality control. Rigorous quality control measures are implemented at each stage of production to ensure the purity, potency, and safety of EcoShield Plus. Microbial contamination is tested, probiotic viability is verified, and the presence of bioactive compounds is assessed. Packaging and storage. The packaging containers used for EcoShield Plus are coated on the inside with nanotechnology-based nanoparticles. This coating forms a protective barrier, minimizing oxygen and moisture transfer and enhancing the shelf life of the product. Suitable packaging materials are used to protect the probiotic formulation from external factors that could compromise its quality. Distribution. The final product, EcoShield Plus, is distributed to various outlets to ensure its availability to consumers. Through a well-established distribution network, EcoShield Plus reaches consumers who can benefit from its probiotic properties. The conclusion being, the production process of EcoShield Plus involves careful selection, preparation, and formulation of diverse and potent lab strains. The addition of natural ingredients, extraction and concentration, quality control measures, and suitable packaging ensure the purity, potency, and freshness of EcoShield Plus. This meticulous process guarantees that consumers receive a probiotic product with superior health benefits. Thank you, and I'll pass on the presentation to the next group member now.
Hi everyone, my name is Nur Elina Fahira and now I am excited to share with you the expected outcomes of our groundbreaking project focused on developing the Ecoshield Plus biopreservative product. Through our meticulous research and scientific methodology, we anticipate achieving several significant results that will revolutionize the industry. Firstly, we aim to identify and select potent lactic acid bacteria strains with probiotic properties. These LAB strains will be carefully chosen for their viability, stability and compatibility, ensuring the highest quality product. Secondly, our project will focus on the efficient extraction of bioactive compounds and probiotic metabolites. We will develop and optimize extraction methods to ensure the maximum yield and purity of this valuable component, enhancing the effectiveness of Ecoshield Plus. Moreover, we are committed to the development of a superior formulation of Ecoshield Plus. By incorporating 100% natural ingredients such as cinnamon, cranberry, and green tea leaf extracts, we will create a formulation that not only preserves freshness but also offers added health benefit. Furthermore, we will formulate Ecoshield Plus into a convenient dosage form such as powder and liquid form. This will ensure easy consumption, accurate dosage control, and enhanced bioavailability, making it accessible and user-friendly for consumers. Lastly, we understand the importance of proper storage and distribution. Hence, we will establish optimal storage conditions to maintain the viability, stability, and efficacy of Ecoshield Plus. Additionally, we will implement a robust distribution system to ensure the timely delivery of the product to various outlets, guaranteeing its availability to consumers. In conclusion, these expected outcomes represent our commitment to provide a groundbreaking biopreservative solution. We believe that through our rigorous scientific methodology and dedication to excellence, Ecoshield Plus will revolutionize the field of food preservation, contributing to a more sustainable and efficient industries. Thank you so much.
Assalamualaikum and hi doctor, I am Najwa. So before we go deeper into the further impacts, I would like to highlight some of the main alarming issues on food sustainability that is currently happening in the entire world right now. Food insecurity and shortage is believed to be one of the most concerning challenges since 2018, and food wastage is the main reason behind the food shortage challenges. So currently, there are no preservation methods that are believed to be sustainable, which made a well preservation of fresh fruits and vegetables post-harvest. So this remained as a huge problem. So the poor management during post-harvest have made a significant losses of fruits and vegetables from 25% to 40% prior to consumption. Current conventional methods leads to nutrient loss and degradation of sensory and nutritional characteristics. Also, chemical preservatives are widely used to preserve food, especially the fruits and vegetables, which is way too harmful to human health and environment if the chemical preservative is overused for a long term. So, the increasing concern of consumers about food quality and safety and their rejection of chemical additives has promoted the breakthrough of the biopreservation field and the development of studies on the use of beneficial bacteria and their metabolites as potential natural antimicrobials for shelf life extension and enhance food safety. For this purpose, products which maintain their quality attributes throughout a relatively long shelf life, from production until consumption, are in increasing demand. In addition, food quality and safety requirements must be strictly met, considering also the nutritional value and sensory properties of the end product. However, various factors should be taken into account when choosing the most suitable preventive and control methods, such as the impact on the characteristics of food products, consumer perception and acceptance, food storage conditions, costs, and etc. In addition, fungal resistance toward chemical preservatives has been reported recently. The health concern with food safety issues and demand for natural, less processed, or preservative-free food products from consumers are increasing. In this context, the development of new preservation technologies as alternatives to chemical additives is very urgent. So in recent years, using microorganisms or their metabolites to control unwanted organisms and extend food shelf life and increase food safety has gained increasing interest. So currently, biopreservation by lactic acid bacteria is the most promising alternative candidates to chemical preservatives in dairy industry due to their generally regarded as safe GRAS status and qualified presumption of safety QPS status in the United States and Europe respectively. The antifungal activity of lactic acid bacteria against spoilage molds has been studied not only in laboratory media but in a range of fermented food products such as yogurt, cheese and bread. In recent years, the demand for clean label food products from consumers has been increasing, so lactic acid bacteria or LAB and their bioactive metabolites are considered the natural chemical preservative replacement for use as the bioprotective tools in food to control the fungal spoilage and satisfy the consumer demands and legislation. So the production of antifungal metabolites and competitive exclusion might be the main mechanisms of LAB for fungal growth inhibition. However, although numbers of studies have reported the antifungal efficiency of LAB cultures and or bioactive metabolites in food products, only few LAB cultures are commercially used up to now. It is likely that some constraints may hinder the commercialization of the candidate antifungal LAB cultures. Not all the criteria of bioprotective cultures in food products have been thoroughly satisfied. The first constraint concerns the safety issues. The safety assessment and risk analysis of the selected LAB cultures or their antifungal metabolites used in food preservation are the key points linked to the antifungal efficiencies and product quality issues. So therefore, it is crucial to take multiple criteria into account and follow the rigorous safety assessment procedures. The second constraint seems to be the gap between an efficient antifungal activity in laboratory media, in vitro, and the actual antifungal activity in a real food matrix in situ. Thus, it is important and necessary to carry out a challenge test to evaluate the actual antifungal activity of the potential LAB bioprotective cultures in the real food products. As previously stated, a variety of antifungal compounds can be produced by LAB cultures, which is regarded as the main antifungal mechanism. According to a previous research, a number of bioactive compounds have been identified which are likely to act synergistic or additive bioactivity. In this context, the identification of new antimicrobial compounds which are in low amounts is hampered in complicated food matrices such as yogurt. In addition, a number of low molecular mass compounds with antimicrobial activity might remain unidentified because of the lack of efficient technology. Therefore, development of new sensitive detection approaches for low molecular mass compounds identification in food products should be considered. Furthermore, the combinations of LAB cultures or antifungal compounds should be further investigated, understanding the synergistic or additive effects. These combinations could be employed as novel biopreservatives to extend food shelf life. From a consumer perception and legal viewpoint, the use of competitive cultures is non-controversial since no antimicrobials are needed. However, to what extent competitive exclusion by LAB, lactic acid bacteria, plays a role has not been studied in depth. So the role of competitive exclusion on the overall antifungal mechanism of LAB in various complicated food matrices remains to be further elucidated. In addition to the antifungal metabolites produced by lactic acid bacteria cultures and competitive exclusion, the relationship between the physiology of the spoilage fungi and the antifungal mechanism behind LAB cultures or bioactive compounds is required to be understood. Here at Ecoshield Plus, we strongly believe that LAB cultures and their bioactive metabolites are promising candidates as the natural alternative preservatives which not only reduce food spoilage and wastage, satisfy the demand for clean label products from consumers, but also conserve economic and environmental resources. This is why we are called upon to invent Ecoshield Plus to ensure a food sustainability for the future. Better food, better life. Thank you for listening.